So for our second video, we're going to tackle the right half of this worksheet here, the 5.5 notes. You may have noticed already that problems 8 through 11 we're being asked to take one log and convert it into the sum or difference of logs. So we're taking an individual log expression, we're going to separate it so that we break it down into its smaller components. And each one of these methods or strategies that we're using are going to be helpful at one time or another. Sometimes you have to take a bunch of logs and convert it into one, and sometimes you have to take one log and split it up so it makes it simpler. Okay, so anyway, we're practicing the breaking one log up into simpler parts. We know that the log of a quotient is the difference of the logs, and so we get log base 19 of 6 minus the log base 19 of 17. There's no way to simplify that expression anymore if we didn't, if we're not going to use our calculator, then there's not really any way to simplify that, so we're going to leave it alone. That's it. Okay. And there's no powers. Remember, it says express powers as factors, right, as the sum and or difference of logs. And so we did that. So no big deal, just split it up. Okay, well this one, number 9, we have a little bit more work to do, but nevertheless we write the log of a quotient as the difference of the logs, and so if you keep saying that to yourself, it becomes second nature. So we have log base 5 of x to the 4th minus the log base 5 of y to the 8th. Okay, well notice that we have exponents up here and we can't deal with those. We don't, or at least, sorry, we can deal with them. It's just that the instructions tell us to express those powers as factors, and so we know that we use that property number 4 in the properties of logs to bring the exponents out in front and make them factors. So we have 4, the exponent of 4 comes out front, and we say 4 times the log base 5 of x minus 8 times the log base 5 of y. And that's it. That's all you have to do. Nothing scary, other than looking at number 10. It looks a little bit scary. Number 10, we have all kinds of stuff going on here. We've got radicals and products and quotients, and so let's just take it step by step. We write this as the log base 7. Notice we have a quotient, so the log base 7 of the numerator. So we have, I don't know why they'd put a 2 there, it's a square root. So the log base 7 of the numerator minus the log base 7 of the denominator, because the log of the quotient is the difference of the logs. Okay, and then now we have the log of a sum as well, and I may need a little bit more room down here, so I'm going to do that. Give myself a little more room. Okay, and again, the log of the product is the sum of the logs, and so we write log base 7 of cube root of x. Now, if you don't mind, I'm going to write the cube root of x as x to the 1/3. That way I can save myself one step, and I can write the square root of y. So again, we have the log base 7 of a product, and so we have the sum of the logs. And when I write the argument square root of y, instead of writing it as square root of y, I'm going to write it as y to the 1/2, and then I can leave this other one alone. Now you may notice that we could have done that whole step here, this one right here. Let me do that in a different color. So this whole step right here, we could have eliminated that step by recognizing that we have the log of a product, and so we have the sum of the logs there minus that log of the denominator. So we could have done that, but I wanted to show you how we get to that step using that first step there. Okay. But now, again, notice that we've got these exponents, and we're told we're not allowed to have those exponents in our answer. And again, that's very important that we can see that we can move those. So anyway, we get 1/3. We bring the 1/3 out front. We're going to bring the 1/2 up front, and we're going to bring that 2 up front as well. So we have 1/3 times the log base 7 of x plus 1/2 times the log base 7 of y. And then finally, minus 2 times the log base 7 of z. Okay, and that's it. That's all you have to do. Okay? All right. Let me put a box around this, make it look nice and tidy. And we'll see I have to pause, and you don't need to know what I'm doing, but I'll see in a minute. Okay, I wanted to make sure I had plenty of room for this one. Again, we're in the same category of taking one single logarithm and expression and totally dismantling it almost and separating it into simpler logarithmic expressions, which again will be important at one point very soon. So we have the log of, notice that we have the log of a product in the numerator and then divided by, again, something else. So we have log of a product up here and then ultimately the log of a quotient. So let's do that all in one step. We have the log of, since the log of the product is the sum of the logs, we're going to write the sum of the logs here. Log of 8x plus the log of, oops, not log, it's ln, of the 11th root of 1 plus 4x. And then, again, the log of a quotient then is the difference of the logs. Okay, so the log of the quotient is the difference of the logs. So we have ln of x minus 6 raised to the 9th power. That's why we see the x has to be greater than 6. In this case, you can't. X needs to be greater than 6, otherwise you'd be taking the log of a negative number here, or 0 even. And we can't, notice here we can't leave this product here. This is the one step that students forget about. They forget, oh, I've got 8x there. No, you got to also express that in terms of simpler logs. And then we have this radical here we need to get rid of, and we need to get rid of that exponent over there as well. So the log of this product here is the sum of the logs. So we have log of 8 plus log of x. And I'm saying log because it is a log. I know we normally say ln. Okay, plus the log of 1 plus 4x raised to the, now 11 is the root. Okay, and roots grow in the ground. So if roots grow in the ground and that fraction up there, fraction bar represents the ground, then a root must go underneath that. So in case you needed some way to remember that, there you go. And then we bring again the 9, the exponent out front. We have 9 times the ln of x minus 6. And again, common to say, oh, we got to break this up. Well, no, you can't break that up. The log of a difference is not the difference of the logs, and the log of a sum is not the sum of the logs. So these need to stay alone, stay intact. Okay, 1 plus 4x and x minus 6. Those need to stay right where they're at. You can't simplify those anymore, but you can simplify this 1 over 11, and let's go ahead and do that. We have finally the ln of 8, so that's our first part, and then we have plus ln of x. We can't simplify that anymore, plus the bringing the exponent out in front, 1 over 11, multiply that by the ln of 1 plus 4x. Do not even think about splitting that up, like I said. Minus 9 times the ln of, again, don't split this up either, the x minus 6. Okay, so there we go. We've got that expression right there, and that's a granddaddy problem. You're in the big leagues if you can do that one. So you just did, so nice job.